Can you guys hear me fine? OK, great. Hi, Portugal. Hola, Portugal. It's my very first time here. My Portuguese will be very wrong. If it's wrong, kindly adjust. But the intention is this, saying hi. So let me start with this slide. Writing software is easy. How many of you agree with this thing? One? Just two? OK, few people. Great. So yeah, writing software is pretty easy. You might get frustrated at times, but it's easy. But maintaining them is the most scariest part in your software development or deployment or whatever you consider. Why? Automatic deployments. How many of you have to do this stuff? Automatically deploy your stuff. Scaling. Another problem. You have to scale it. Once you start scaling it, you have to add a load balancer on top of it. It kind of takes you away into a different territory. And the final problem is high availability. When you're trying to do microservices or any services in general, the general intention, if you're using that product, your intention, it should be highly available. And if you're creating that product, everybody's intention is to make it highly available. And these are the problems that we face on developing applications today, correct? Yep, so welcome to my talk, Easy Microservices with Kubernetes and Istio. I'm Sendil Kumar. You can reach me at this handle, Sendil Kumar on Twitter. I'm basically from southern part of India, Tamil Nadu, and I'm currently living in the Netherlands. So who am I? I'm a full stack developer at Zebia Labs. We have DevOps products. If you want, you can check us out on our website. I'm very passionate about open source. I've been talking a lot about open source, working a lot on open source. The general philosophy for me in open source is like it gives me an opportunity to learn different things, and I get to enjoy that stuff. I'm a core dev team member at JHipster. I'm also created a thing called Kotlin Hipster, which kind of replaces a Java backend with a Kotlin backend. And I'm also a team member at Webpack and Rust-Wasm. How many of you are full stack developers here? Sharing the same pain. Few. Backend? OK, many. Front end? How many of you like JavaScript now? OK, we have two. OK, how many of you like JavaScript? OK, we have few. Good audience. So what we are going to do today, the very first thing that we are going to do is like we'll see Kubernetes. How many of you used Kubernetes before? Few. OK. So just like Kubernetes 101, but kind of we'll see what we can do with Kubernetes. And then we go forward with Istio. What is Istio and where it helps in your microservices development. And then we go to JHipster microservices. Question, how many of you used JHipster before? OK, how many of you like it? Everybody? Great. And also, let's see about CI/CD options that JHipster actually creates. And this was from one of my tweets. Somebody tweeted me that they want to add the CI/CD stuff into the presentation. So I've just added CI/CD stuff. Let's try creating a project and then add CI/CD stuff. And then see how JHipster helps you there. So let's get started. Kubernetes. So Kubernetes is an open source system that helps you to do automatic deployment, which is a pain that we saw. Scaling, which is another pain that we saw. And also management, which kind of helps you to do high availability, managing, and all those things for all the containerized application. And Kubernetes is becoming the de facto standard for all the containerized applications, right? Kubernetes makes that easy. Whatever it is trying to do, it makes it easy, and it makes it really simple. Correct? Correct? No? But we need to understand Kubernetes. How many of you here fully understand Kubernetes? The people who have... Nobody? Nobody? Yep, Kubernetes is a huge thing. It makes your work somewhat easier. But what Kubernetes actually does is actually trying to solve all the pain points that we've seen in the first few slides. So it's trying to solve all those things, which is a pain point. And Kubernetes has to cover different scenarios, multiple different applications. It's a language agnostic. So it has to do a lot of things, which is kind of a pain. So we will see what Kubernetes is all about, how it's made up of, and how it is working under the hood. And then probably we'll get to see some Kubernetes configuration file, and then match these two things together. So obviously, Kubernetes has a master node where everything runs. So this is a guy who sits there and issues order, just like any master would do. And you have some nodes, or the worker nodes. These nodes where you have some processes that are running, which kind of helps you to boot up all your applications. So the thing that is on the side is Kubernetes LAN. So whatever comes here is in the Kubernetes server. So you have a Docker file. You have a container. Consider that as a container, small blue box. You create an YAML file for that container, which looks something like this. It uses the container image. This is just simple a YAML file. And what you do is like, you do this kubectl apply -f for some.yaml, the some YAML file that we have written. Once you have done this, what it does is like, it goes and connects to the Kubernetes API server. And this is a server which acts as an interface for your Kubernetes master. So it goes and connects to the master via the API server, and then sends this file inside it. This API server is responsible for validating, and also it sends the content of the content to the controller. The controller guy over here, he's the one who sits there and checks all the things that is coming to him, and then does go ahead and store that in an etcd. So what is an etcd here? Sorry? No. Storage, yeah, it's a storage. It's a key value storage. And finally, you have the scheduler. So once you get some information on your database, the database goes ahead and puts that thing into the queue of the scheduler. So scheduler obviously have a messaging queue. It puts that thing inside here. So what you have said here, you said that you want some deployment. So what it does, it creates a deployment, goes to the API server, and from API server, it goes to the controller, it stores an etcd, and then says your scheduler, OK, go ahead and create me a deployment. So that's what's happening. And this entire block is the control plane in Kubernetes, which is the brain of the Kubernetes. So this is where all the work happens. And this is the master node. This is the job of the master node. So once that has happened, once the scheduler gets the information, it goes ahead and looks. Oh, I pressed too fast. It goes ahead and looks for any available nodes in the master, or any available nodes in the cluster. So Kubernetes has a cluster which has multiple different nodes. So it goes and checks to which node it can actually deploy the configuration that you specified. So it signals the start of the deployment to that particular node, and your deployment will start. So this is how Kubernetes works under the hood. But of course, you're seeing about worker node. Worker node has some kubelets on top of it, which is the actual thing that deploys your application, the containers. You need to have somebody to sit there and connect this entire thing to external environment, as well as among themselves. So you need someone to connect it. And that connection, or that networking, is handled by the kubeproxy. So kubeproxy is the one that helps you to connect your pods to external internet or within your pods. So this is a guy who sits there and does everything. But in the world of Kubernetes, we have seen a lot, right? Deployment. So what's the deployment? Anybody working on Kubernetes? What is a deployment? No? No? OK, so deployment is an image that contains information to run the container. So it's actually something that you say, OK, so I want to create an Nginx server. And it goes ahead and say, OK, go to this container that is Nginx, the last few lines, Nginx 1.7.9, and then run that on the port 80. So this is what deployment is all about. It's just an object that lives in the Kubernetes. Replica sets are something that manages and monitors the replicas. So you can say, like, run 2 replicas of this, run 3 replicas of this. So with this, you can have replication of your service. And pod, it's like an object that contains 1 or more Docker containers. So that's what a pod is all about. Services for load balancer, traffic, networking, and all those things. So this is just 101 stuff. But one thing that you have to understand when you're working with Kubernetes, as well as with Istio, is the networking side of it. So how many of you are familiar with the networking here? 1, 2. How many of you love setting networking in Kubernetes? OK, let me put it this way. How many of you tried creating a pod and then don't know how to access which IP to use to access that particular pod or service? How many of you tried that? How many of you have that experience? Everybody, right? So yeah, so the networking side, you have 3 kinds of networking. Load balancer. So obviously, you have your services that are running. Services are nothing but a load balancer that are running. So when you say it as a load balancer, you'll create an async load balancer on the master. And this load balancer will have an external IP through which you can connect. That's what this is. And in terms of node port, all your services will have their own nodes, ports. And you have a single Kubernetes IP address with which you can connect to those nodes. In Ingress, it has multiple different IPs. You have a controller IP with which you can connect. but it doesn't have an external IP, which means like you don't have some external IP through which you can connect to your system. You have to go through this ingress controller. So that's the main difference. So let's go ahead and see the sample Kubernetes stuff. So let me go inside. So is it visible? Is it OK for everybody? OK, great. So what it has, is it visible? Fine. OK. So what it has, let me go here. It has a sample app. And it's just a Spring Boot app written in Kotlin. It doesn't have anything else apart from this one single line, one single controller. And what does it do? It takes get mapping of hi/name, and then it goes ahead and redirects and gives me this output. That's it. So let me try running this one. So it runs on port 8080, and it doesn't have anything else apart from this one particular endpoint. So let it start. So as you can see here, it has nothing, just a single stuff. So what I'm trying to do now is like create a Docker image out of it. So I have a Docker file already. So what it does, it uses this particular Java 8 image, and then it copies the jar that I'm going to create, and then put it inside the user app, inside the container, and then run the jar. That's it. It doesn't do anything else. And once I have created the Docker image, I can go inside my service app YAML. So this is where I'm kind of defining my deployment for Kubernetes. So I'm specifying all this metadata are labels. If you want, you can add it, or else you can leave it. I'm specifying just have one replica of it, and all those version information. And this is where the important information lies. OK, so here I'm specifying the name, Spring Boot sample, and the image, sample Spring Boot, the image that I'm going to create. And I'm specifying image pull policy never, which means like don't go to any Docker repository and pull it. I have it in my local, so I'm creating my image in the local, so just take that image. And I'm specifying some resources and the port in which it has to run. So let me go back to the Kubernetes folder. And I have my kubectl running. And let me double check it. So yeah, so Kubernetes is running. And it's in Docker for desktop. So all I have to do is apply this particular file. It has to be created. And then I go ahead and apply a service. So what is a service here? Service, again, is a load balancer thing, which kind of helps you to access your services, access your deployments. So I'm specifying, OK, so go to this port and do the stuff. But one thing here is like I need to have the type. So I can specify a type here and then say it's a node port. And another cool thing about Kubernetes is like whatever configuration that you're changing, you can just go ahead and run this. So now it's running on a node port. So I can go ahead and check kubectl get pods. So my application is running. Get service will give me the services that are running. And I have something running on this node port. So remember, the Kubernetes, when you're specifying a node port type of networking, you have to access the application via that network. So you can just go ahead and see localhost, this guy, hi, JNation. Hopefully it should work. Yeah, so it goes ahead and returns me this hi JNation thing. So my application is currently running on a Kubernetes cluster, and it's giving me it's returning me something that I'm expecting. So that's what Kubernetes is all about, right? So you can just go ahead there, and you can change this guy to have 2 replicas. And I can just apply this guy. So this will create a 2 replicas. So I can see it here. So you can see the 2 replicas are running here. So it creates me 2 replicas of the same services. So it's kind of running. So everything is working under the hood. Great. So I can also go ahead and kill the pod, kubectl delete. Now I can see to this get pods w, which kind of watches. And then I can say kubectl delete pod. So I can go ahead and delete a pod. So what will happen is like it will terminate it, and then it will go ahead and restart the application again. So because my deployments are still active, which means it has to, oh, sorry. Okay, since a heavy load is running on my machine, it's taking a bit. But what happens now is like I'm deleting a pod, so my deployments will stop running. And then you can just see the Kubernetes cluster will recreate everything for me, and it runs together. OK, let's wait for that. Before that, let's go to Istio. So Kubernetes always specify the desired running state of your application. And Istio, how many of you have used Istio here? 1, 2, OK, great. So what's a service mesh? Is it right after the lunch? No, right? You had a session in between, right? So what is a service mesh? OK, so service mesh is a network of microservices. So you have a network of microservices that can interconnect between them. That's the basic thing of service mesh. A service mesh is nothing but a network of services that can interconnect between themselves. And what Istio tries to do is like you have multiple different services, service A, B, and C, and you have some functionalities that is common across those services, like logging, monitoring, and networking, how to log all the things, how to monitor all the services that are running. These are common functionalities that live there. So what you can do is like plug all those common functionalities away, put them as a separate stuff, and then run your services with all those common functionality. And that's what Istio is trying to do on a higher level. So but how Istio does that? So what Istio does at the very first stage is like you have an application that is running inside a pod. So a pod will have one or more containers. So here you have one container that is your application that is running inside the pod. So what you do is like inside the pod, you enlarge the pod and add a proxy to it. So this proxy is nothing but envoy proxy. Anybody knows about envoy proxy here? A little bit. OK, so envoy proxy is a lightweight C++ protocol that lives along with your service that helps you to connect your service from an external environment. It is platform-agnostic network abstraction. So you just have to boot this proxying service side to your application, and it kind of runs everything together. So that's what envoy proxy is all about. So I have an application and envoy proxy, but somebody has to instruct this envoy proxy, right? Somebody has to tell which services to let in, which requests to let in, which requests to block, and how to monitor these things. So for that, you have something called mixer. The mixer is a component from Istio. So it does like policy control. So you can specify to the mixer, OK, just allow the request that is coming from X location. Just allow the request coming from Y location, things like that. So it helps you to do policy control. And also, since you have a single stream through which all your applications will be accessed, now you have a mechanism to collect all the logs via it. So this is one endpoint through which you get all the logs, or all the requests go through this mixer. So your mixer get to know what is happening inside your application, and it gives a single endpoint for telemetry collection. So that's what mixer is all about. So where does mixer get its information? Mixer gets it from the control plane of Istio. Again, the control plane is the brain of the Istio. So how the control plane looks like? So control plane actually has a pilot. So here, all the Kubernetes stuff has a naming convention. So Istio obviously has a little bit of aircraft or air domain stuff. So you have this pilot. And the pilot is the one that helps you to do service discovery, which means it can help you to find the path in which you have to send a request. For example, you can specify the pilot. If anything that comes with /API/any request or service A, just redirect that to the service A, which is running on port 8082, or which is running on the particular container. You can specify it. A pilot is the one that is responsible for navigating that stuff. And you have galley. A galley is something where you validate, process, and distribute all the configuration that you're giving to Istio. So a galley is a one where all the configurations will be collected. And this is a guy which is responsible for sending those configurations to pilot as well as to other terms. So that's what galley is all about. and Citadel. Citadel is for authentication and authorization. So you can think of galley as the trolley which in aircrafts people used to bring. The cabin crew used to bring all the foods inside it. So that's what galley is all about. Similar to that, galley will have everything inside and helps you to validate and then send those requests or send those configuration down the stream to the mixer. And in mixer, everything gets configured and it connects to the proxy. So any request that is coming in will go through this path and go to the mixer and then go to the proxy, and the proxy where all the decisions were made, and it connects to the application. And this side, the mixer and the proxy and everything is called as data plane. And basically, this is what Istio does. The website says they do 4 things: secure, connect, control, and observe. So Citadel is using for securing, pilot to control or navigating, galley to connect, and mixer obviously has telemetry collection, which helps you to observe things. So let's go back. Hopefully, our application. Okay. But you can see it started to delete something, and then it terminated it. But again, it found, OK, so it's terminated, it's pending, and then it restarted it again. So that's how Kubernetes pods work. So you delete something, it goes ahead and recreates it. How do you clearly delete it? You can go ahead and delete the deployment. Or you can just delete from the file through which you have created. So you can say delete -f service and sample app. OK. Why are you so slow? OK. Let it kill it. Let me go here. Yep. So this is the Istio configuration file that we have seen. So what we have to do is like we have the sample app.yaml, which boots up the single container. Now what I have to do is like I have to add Istio proxy inside it, the envoy proxy inside that application. How I can do this? I have something configured already. So here I'm adding an annotation that says, OK, so add a sidecar to the Istio service. So add the sidecar to your deployment object. So what it does when it creates an object, when it creates a deployment for you, it creates the first part, which is your application, and then it creates another part that's a proxy through which it runs. And the container has the same thing, but it also adds certain arguments. So these are the arguments that helps for you to understand, or for Istio to understand how to connect to that particular application. So this is what happens inside. But adding an Istio is for adding another level of abstraction on top of those pods, right? So how you can add that abstraction is via the gateway. So in the gateway, you can go ahead and specify, OK, use the gateway of Ingress. So I'm using Ingress gateway, which means it has an internal IP attached to it. And for any port 80, anything that I connect will have to go through this Ingress gateway. And here, I create a virtual service. This is a service that lives on top of this everything, which specifies, OK, so if the connection is coming from this gateway, and it matches having a prefix of Ola, rewrite that particular part into UI, hi, and then go to the destination, which is my application that is running on 8080. So this is what it tries to do. So let me go there. Let me first delete this one. Ouch, sorry. OK, so everything is deleted. My pods are empty. So all I have to do is like kubectl apply. I can do this. So what I've done is like applied this entire folder, which means whatever YAML files that lives inside the folder will be applied straight away. And because my machine is so slow, it will take a bit of time to complete this. Let's go back to the slides, and then we'll come back here. But this is what will happen. So it will create all those things for me. And once it is done, I can just go ahead and access Instead of saying hi/JNation, I can just go ahead and say /hola, just /JNation, which redirects to hi JNation and then returns the correct URL, correct stuff that I'm expecting. Okay, something has happened. It's booting up, it's terminating something. So let's wait for some time. Let me go back to the presentation. So microservices. How many of you are doing microservices now? Okay. How many of you are enjoying it? Okay, few. Okay, great. So what microservices actually helps you to do, it has individual development, so you can develop at any different location, physical location or geographical location, anything. It also helps you to do individual deployment, so you can have multiple different versions of things that is running and putting it somewhere else. You can, the very big good thing for me is like you can do this fault isolation, which is kind of like if you have any of your service that is failing, you can just remove that service out of the picture and then run it together, so it kind of does the fault isolation stuff. And it also adds in this granular scaling, which is kind of like you can increase certain things, we can decrease certain things based on the resources, based on the expectation, based on the load, and all those things. So it does it very clearly and easily. But one of the problems with microservices or migration to microservices is like, consider the big chunk is a monolith application, which is your monolith. So the problem inside the monolith is actually inside this monolith application itself. That is the problems that you usually face in a monolithic application, or something that is because of the code that you have written by your hand or by the keyboard. But in terms of microservices, the problem actually lies, most of the problem actually lies between those network of services. You're relying on layer 7 TCP protocol and things like that, which is kind of flaky based on the network, based on the connection, where you cannot promise 100% or ideal environment anytime. The problem lies over there. So it's very difficult to fix that part. That is one of the basic cons of microservices, right? So it kind of like you have to think about that solution. You have to create a, you have to do Chavos testing. You have to create something that has like high availability always, that has multiple different things running around somewhere, and a mechanism to connect to it, and a mechanism to check health for that. These are some problems that are attached to that thing, because your problem actually goes between those services where it's very difficult to connect. So that's a brief introduction of microservices you can take, but microservices with JHipster is what we are trying to do now. So what is microservice? What we generate for a JHipster. So JHipster is actually Java hipster, which kind of generates a full stack application. And you can choose between various options like microservices or monolith, or an UAA server, or an authentication server, things like that. And also you can choose between Angular and React for generating an application. So the pattern that we have in JHipster is like we're creating something called as API Gateway or BFF pattern. Anybody familiar with BFF here? What is a BFF? Sorry? Yeah, backend for front-end pattern. So that's what we are using. So you have a single application which takes care of all the front-end of your application. And you have multiple different backends which doesn't have a front-end attached to it. All relies on a single application. So that's how backend for front-end pattern is built. So how a JHipster application looks like, an overview of architecture. You have multiple clients that are running somewhere, and that connects to your service. This is the front end of your application. You can choose between Angular or React. We also have a Vue.js, but that is not in the official generator. And you have an user authentication and authorization inside. So all the user authentication happens in the front end of the application. And you also have Zool. Anybody here use Zool? Yeah, one guy. OK, so Zool is a proxying service which kind of helps you to proxy the request that is coming to your front end of the application that goes to the back end that are the different microservices that are running elsewhere. So that's what we use Zool. And this entire chunk is called as microservices gateway, or the gateway of your application through which you are going to connect your clients. And then you have multiple different microservices that may or may not have databases attached to it. And they have different kind of databases. So that's where that lives. So it goes ahead and connects. So Zool is the one guy that helps you to connect from the gateway to the microservices application. And then you have somebody called, you can choose between Console and JHipster registry. They are helpful for doing service discovery. Anybody used Console before? Yep, yeah, few people. Yeah, so you can use choose between Console and JHipster registry. JHipster registry is built on top of Netflix OSS, Eureka, and things like that. So it's built on top of that. And you have Console, which is kind of multi-node clustered. It's very helpful when you're doing multi-language or multi-stuff with microservices. And then you also have something called JHipster console, through which you can see the logs of the application, through which you can see, it's basically an ops module or ops admin module through which you can control all your microservices. JHipster registry also gives you that ability to run different services together. We'll see that in the demo. So what is a JHipster registry? It's basically built on top of Eureka server. It helps you to monitor and manage your application, microservices application. And what's a console? So console is easy to run on a multi-node cluster, and it's always have consistency over availability. That is, all the nodes will provide correct detail every time. So every time when you're trying to check which service is up and which service is down, it goes ahead and connects to all those services, gets the information from those services, and then say to you that these services are up. But in terms of JHipster registry, it works on the registry principle, which means you have a particular set of things that is already available in the registry. It gives the information from that information. And any services that goes down, any services that dies, JHipster registry has a mechanism to collect it ad hocly. So here, it's always consistent. But in terms of JHipster registry, it's all about availability. So JHipster demo time. Let me go back here. Something is running. Hopefully this should work. Let's see. Oops, it didn't work. OK, let me come back to this after we generate the applications. So the easier way to generate a JHipster application is using something called JDL, where you can specify the entire application in a single file, or a stack of microservices in a single file and all its entities. And then you can just go ahead and import that file. To import a file of JDL, you can do JHipster import JDL, app.jdl. So this is the file that is generated. So you can see like I have something called application. So inside an application, I define the base of the application, what kind of application. So you can choose between gateway, microservice, and a monolith. I'm also specifying the service discovery type as Eureka. I'm using a MySQL database. I'm running it on Hazelcast and all those things. And here I have another application, which is an invoice, which is a microservice application. It has its own database attached to it, which is PostgreSQL. And it has some entities added to it. And since the gateway application is the one that will have all the front end for all the entities that you're creating, it has it enlists entity star, which means whatever entities that you're doing or defining in this file will be taken into consideration. And I have my third application, which is a notification application, which uses MongoDB. And it also has Eureka as service discovery. And it runs on 808 port. And then finally, I have product entity, size, category, all those other entities, which what JHipster does is like once it finds this entity, when it generates a project, it also generates a DDL for that particular entities, and also does creation of the database and then maintenance of database really very easy. And it uses Liquibase for doing that stuff. So as you can see here, my applications are currently building up, but you have 3 different folders, one for each application, the store, the notification, and an invoice. So these are the 3 different applications that I have currently running. And my processes are complete, so I have all those things here. So what it does have inside is a plain Spring Boot-based application. And it has a Java folder where all your backend lives. And it has your web app folder where all your front end lives. So it's a basic application that is generated. And the front end is in React. Yes, it's in React, but written on TypeScript. So that's what my gateway application will look like. And then I have my notification application, which has the same structure, but it doesn't have a front end attached to it. It just have this thing. And you can also see it also generates some domain files here. It generates the customer.java, the order item, and everything. These are the entities that is attached to that particular microservice. So it also generates all those POJOs for you. And you can also see it creates a configuration of Liquibase, and then you have this master XML where you define all the Liquibase configuration based on which it boots up the database and all those things. So let's go ahead and run this application. So let me run this. So to run this, I also need a MySQL database, so I can do So all the JHipster application that is getting generated will come with a Docker folder, which has all the necessary Docker files for you to run your application. So here you have MySQL, Sonar for running your Sonar build, JHipster registry for starting a JHipster registry, and all those things. So what we can do is like, we can run this SRC. Then let me take this guy. Okay, so I have to do this. Yeah, I'm just Docker composing and then running. Ouch. Okay. Ooh, okay, so I have a lot of things running. So let me quickly find MySQL here. Okay, stopped it. Sorry. So let me start this. It has to start, so it's initializing the database and it runs. And okay, it doesn't matter because we don't need it because it's starting in a dev environment. So this is not required for dev. Actually, for dev environment or dev profile, we are just using H2 database, which is a local database that will be created autonomously. But the application has been created. The application is running. You can try accessing the application. No. Okay, it was too fast. So application is started, so you can access the application. It's running. It's just the gateway of the application. And you can see all the entities that is present. So the entities are present, which is that you have created. But my entities are not available, which means my backend for those notification is not available. So it throws me an error, which is okay, which is feasible, which is considerable. And also I have a gateway. And this gateway doesn't have any connections to it. So what I have to do is like I can go ahead and start the other services. So let me go to the invoice. And then start this guy. Let me go to notification. Sorry, that was really loud. And start this notification service. And for notification, since I'm running MongoDB, I have to start the MongoDB stuff. Yeah, I'm starting my MongoDB stuff and everything is running and I can access these pages once my application has started here. But one thing to note here is like every 5 seconds I'm getting an error. It tries to connect somewhere and it's throwing me an error. That's because I'm trying to connect it to the JHipster registry, which is my service discovery, through which the application knows how to connect to the different environment. It tries to connect there, but I couldn't do that. And we can do that, we can enable that, or we can remove this error message by starting JHipster registry. So to start the JHipster registry, we can run docker compose src main docker and JHipster registry.yaml up. So what it does is like it creates this. Fine. FNF. Okay. So what it does, it runs the JHipster registry, which will be running on 8761. And once the application is up and running, all those errors that has been thrown by the applications because it couldn't connect will be gone away, and it will start connecting to that application. Let's wait for a minute. So my MongoDB is up, the applications are running. This thing is going to start. Come on, be fast. Okay, let's wait till this happens. But let me go back to the demo quickly. And hopefully this one should work fine. But we have seen so much about microservices Istio, right? So how can we achieve the same thing with JHipster? So I have a microservice Istio application, or microservices Istio. The only difference between the app.jdl that I'm going to describe here is I've specified the service discovery as no. And I've used PostgreSQL database. That doesn't matter. But I've just specified service discovery as no. And again, in my service, a product application, I've specified the service discovery as no. And for the invoice, as well as the notification application, all the different microservices, I specified the service discovery type as no. Which means I don't have any mechanism to connect to the service discovery of the application or any mechanism through which my microservices could connect with each other. What I'm going to use is use Istio to do the same thing. So I have generated my application. I've created a Docker build so I can have this you can see my Docker caches present here from the JIP. So I have this Docker images present on my repository. So all I have to do is make a directory called as Kubernetes. And then go inside the rep folder, and then run JHipster Kubernetes command. So the moment I run JHipster Kubernetes command, it goes and checks for the Docker, as well as it checks for the Kubernetes, whether it's installed, whether it's working. And obviously, my Kubernetes is too slow. Yep. So I have this thing. So it goes ahead and checks. So I just select a microservice application, because for that, I'm going to generate an Istio configuration. Selecting a microservice application, I'm specifying the path in which it lives. I select all the applications which I have to deploy. And it also asks me whether I want to add a monitoring. For now, we are just going to say no here, but if you want, you can add a monitoring. And it found out that I'm using a MongoDB. So running a MongoDB cluster, you can just go ahead and specify whether you want to run it in a clustered environment or a normal environment. I'm just specifying a normal environment here. And a Kubernetes namespace in which I'm going to deploy. It's a default. And the Docker repository name through which I have to collect my image or push my images that I'm generating. So I'm using my own repository. I'm using Docker push. And it asks me whether I want to enable Istio. I'm enabling Istio here. I will use an ingress port. And for this IP, I will go to my application. So I have my Kubernetes cluster that is running here. My Kubernetes cluster is on GKE, and it's running here. And this is the IP through which I can connect to my Kubernetes cluster. So I just have to specify that IP here. And this IP should not be a normal IP. It should be something like .nib.io or a DNS name. So for that, I'm using nib.io, which kind of redirects to that particular IP. So I'm just using it here. It creates me a bunch of files, and then it specifies, OK, push all those images that you have generated. Once you have pushed all those images that you have generated, just run the single command. So let me go ahead and do this, kubectl apply.sh. So what it has, so this is a folder, so kubectl apply.sh. So what it has is, it says, OK, so in the default namespace, just go ahead and enable Istio injection, which means with this property, you can inject Istio, where you don't need to write a separate configuration on all your configurations or all your deployments. You just specify it at one place, like whatever application that you're going to start inside the default, add in a Istio there. And also, it specifies apply, invoice app, and all those things. Ouch. Sorry. So I have to change my Kubernetes context to the GKE or the Google Cloud stuff. Once I've done this, then I can run this thing. Hopefully, it should be fast. Yep, it started creating everything for me. So I have my applications will be created here. You can see it here. So as you can see here, I have my invoice app, which was not present before, and the Postgres database, and all those things. It's running. It's there. So I can just go ahead here, and it gives me an endpoint through which I can access it. So I can click on this endpoint. So my application is currently booting up. That's why it's saying no healthy upstream. So it will take a minute or two for the booting to complete. But my applications are running over here. And also what it does is it also says, OK, so you have this Jaeger, Grafana, and Kiali, which is something that Istio provides by default. So you can add in Jaeger for tracing all your requests. You can add in Grafana for this funky data dashboards and things like that. So it helps you to do everything on top of it. So let's go ahead and see the logs here. Where is the store app? Yep, store app is here. Let me check it. So it is running. Yep, my application is running, and it's running from that particular port. So store a default with an IP that I've given. I can go ahead and sign into the application. And you can see here all those applications are present. I can access it here. Okay, my notification is booting up there, so it would take a minute or two. My product, again, another microservice, it would take a minute or two. But the customer lies in this particular application, so I can connect to it. I can see, but the difference between this application and that is like here you have something called Gateway, and here it doesn't have that gateway. It's because everything is handled by Istio, and my application doesn't even need to know how to connect to different applications because it can connect all by itself. Okay. Let me quickly check one more thing. So this is my JHipster registry here. So this is what I've booted up for the application. So you can see here 3 applications are running currently, and the statuses are up. And here I can go ahead and check the configuration of those particular stuff. I can check the metrics of all the things that is running inside, either be the JHipster registry or the invoice that is or the invoice application or any other applications that I have. So all those things can be done with the JHipster registry. You can also have an health check endpoints and things like that. So that's what JHipster registry is all about. So it has a single point where you can see whatever application that are running inside and how you can configure it. So going back to the slides, and I'm skipping CI/CD because I don't have time. So this is what we have seen: microservices with JDL, Docker Compose, and how to run them together using a JHipster registry, and also Kubernetes plus Istio configuration. I'm just going to skip this thing. You can go ahead and read the slides. I'll publish the slides. These are like limited things. But one thing to highlight from this entire best practices, always when you're trying to write your Kubernetes configuration, try to have this request and limit how much CPU and how much memory that you can have access for these processes that you're running inside it. It kind of helps you to run a better or manage the better resources of the Kubernetes very, very well. And of course, we have JHipster conference that is coming on June 27th in Paris and France. If anybody is interested, you can just come over there. Any questions? And I just have 2 minutes, so any questions? Questions? Nope? Nope? Okay. Thank you very much for that.